Hello, welcome back. This time we're going to discuss the JavaScript closure. So I have my code editor open on the right and the example running on the left. The example is really a later example. The last example we'll look at. We'll start out with the basics of what closures are. So a closure is a function that makes use of a variable defined in the outer function that after that outer function has returned. Here's an example. Make func, and in here, this is a local variable to this method, make func. And then within it, it has this method, defined, display, and notice this is referring to this local variable defined here. Return display. It's returning this function. So when we call it, what we'll see is this hard math, then referring to this local variable, and it will be 2 for it. That's a closure. When this function is defined, it closes over the local variables of make func, any parameters in make func. This is really important. The parameters are probably the most important thing, and also any global variables that are set in their current setting. If the body of this function refers to any of them, then their values are closed over and are known in that state when that function is actually invoked, regardless of what happens to those variables afterwards. Bring up Developer Tools, Control-Shift-I, and we'll see our console. I'm going to clear this and run it again so we'll have a clean case. Let's fix that. Okay, I wasn't actually running in my server, so that's fixed now. So when I refresh this, we see the output that we've wired in here. So make func is called, as we've described. It returns a function that closes over these locally defined variables here. We haven't shown parameters yet and global variables, but it does that as well. Closures do. Return display. So here, what my func is, it's the function, and here we invoke it through this handle here, and that causes 4 to print on the screen. And this is an alternative way to call it. So here, this really manufactures another closure at this point. Make func this, and then invoke what it returns. So remember, make func returns a function, and then the second set of parentheses mean invoke that function, and that's what we see right here. So let's go to a little bit more difficult example. At least it has more elements for the closure to close over. So this one just had the local variable. So this remember then call has a parameter. I have a global variable y here, and I have a local variable that takes the parameter, adds 2 to it, and then concatenates with this global variable. And all of that, still called hard math, all of those elements are closed over and then used when the display is called. So we have, remember the call in this time we pass it 3, so then it'll be 3 plus 2, but then A will be used, and then B will be used, and then this will the value of n will change to 30, and then the value of y changes to C, and then the parameter changes to 300. And as we see when we run this, all of those aspects are closed over and therefore remembered. So this is actually the definition of the closure. So this is essentially a function factory that has returned a function set up in a certain way due to the closure. F3, F30, F300, all functions in here, we invoke them and we'll see the result. And let's actually watch what happens in the output window here. So we see 5, 32, 302, and then 12, and closure says 40, and then they print out in reverse order. Let's see all of what's happening here. So remember the call, closure, passed 3, 30, and 300, and then always change the local variable, and you can see all of that information was captured. And so when the functions were actually invoked here, here, and here, the closure is producing values based on what it closed over. Furthermore, subsequent closures don't interfere with previous closures. This is closed over and captured in F3, It doesn't matter that the parameter or the global variable changes in between. Then I use these same closure functions in timeout mode, F3 at 4 seconds, F30 at 3 seconds, F300 at 2 seconds. So remember, this is asynchronous, so it just goes through here, sets all the functions. So that's why we see them coming up in reverse order, because the timeout for C expires before the timeout for B, which expires before timeout of A. This is actually 12, and closure says 40 are tests down below, because it just goes on, and meanwhile the timeouts are expiring and then happen later. So you see that the closure continues to remember the values that it closed over, regardless of whether it's immediately called or called within the same context or called via a timeout function. So in the next example, we really talk about, I think, what will help you understand the nature of closures and why they're extraordinarily useful. We've seen the ability for them to capture information and then be called later, encapsulating that. So let's see really what the way they're used in industrial JavaScript. So in associating data, especially parameters, right, I think if parameters are more important than the current settings of local variables. Those could be set based on parameters and also global variables. It's much more clear what's happening if you close over parameters. So you are creating an object with a single method. So that method's object data is the set of parameters it has closed over when it was created. So it's an object with properties that it closed over. Let's look at this function here. This is actually an anonymous function. Previously I used return named functions. So make sizer, size is passed in here, and it takes there's the document.body.style.font size, changes the size of the font size. So we can identify it as a closure because it captures the parameter that is used. If the return function doesn't capture a parameter, it's simply a function that returns a function. It's not a closure then, right? It has to capture some aspect of its parameters, local data or global data, in order for it to be referred to as a closure. But it does, and its intent is to actually change the size of the text on the screen. So again, helpful to think of what this function returns is an object with a single method, and it has object data. It has however many parameters you specify become the object data for that single function. So we'll go over this comment in a minute. Let's take what's happening here. We make 3 closures: make sizer 1.2, make sizer 1.4, make sizer 1.6, and you can see what that is. By the way, the M unit is based on a single letter. It's basically kind of a play on M. That is it's going to be 1.2 the size of the parent element. So it's a relative size rather than a specific size element. 1.4 the size of the parent, 1.6 the size of the parent. So now we've defined the closures, and let's take a quick look at our HTML elements, and we'll see. I have 3 buttons here, and I gave them IDs. The IDs are so the JavaScript can get these elements and address them. So we have size 12, size 14, size 16. These are the buttons here. We define an event handler there, right here on the fly. We take these IDs and get the nodes, and then we define a click handler for each one of those those buttons, and then we associate that click handler with the closure that we made. And this is a good illustration of how closures work in JavaScript and why they're really useful in JavaScript. So a lot of JavaScript is built around the UI. It's built around the document object model, and so there's a lot of events happening. One of those events typically triggered by the user. There's actually a flood of events that are coming in a mouse-driven system. You have mouse move events, mouse click events, double click events, spacebar events, keyboard events. All of those are events that you can hook in with browser. The browser knows about them and is pumping through the JavaScript system. You just have to stop and look at them in order to get it. And this time we're going to capture the on-click method, but they're constantly happening. Right click, left click, double click, mouse roll. All of those things are generating events, and here we're going to capture them associated with these handler methods that are in turn closures that have this inherent information, and you'll see how the font sizes then changes. So we're going to actually click this, so 12, 14, 16, and you can see how the size on the screen changes. These changes of the font size that are actually on the root element of everything here, because you can see how the JavaScript is addressing it. Document.body.style, so the body element of the document object model. Paragraph end buttons are inheriting that change, but as we see, the heading is not inheriting that change. Let's uncomment out these 3 lines of code. So set interval is like set timeout, with one difference. Set timeout calls the callback method once. This sets it up to call the callback method on an interval every 3 seconds, every 1 second, every 2 seconds. And you can see what's going to happen here as we set these intervals. Save that, and refresh the page. And there we see as the different sizing methods fight for the screen. The timeout that occurs most often, size 14 there, every 1 second, will dominate in terms of the length of time that'll be on the screen. So there we go. So callback methods, again, let's review how really this last example, because really this is the practical example of why closures are useful in JavaScript. Inherently, you're responding to events in JavaScript a lot, and in those events you can, with a closure, capture certain behaviors and then hook into different events those behaviors. Right? So customized according to the parameter that you used. And these don't have to be fixed values, constant values. You can determine them at runtime as well. Make as many closures as you need and hook them up to the events. And then you've coded your event handlers that are customized to the type of data and the type of response that you want. Remember, think of the closure as a class, or an object that has a single method, but any type of data that you want to add to it. Thank you.